So go and reduce our So we are starting by exactly 8:10. So we have 2 minutes. We just want to wait for some people to join so we can start. So it's already 8:10. We will start now. So the first 1 hour we use it to do a recap for what we've done in the previous class, the first and the second class that we did before. So that's what we use the first 1 hour to do. And the second 1 hour, we start with some little sketch problem. We use it to tackle some little sketch problem. So let's start now. So if you have your software with you, can open it and follow me. Down, down, down. So like I said before, if you want to enter the software, if you open it, just click on the new file to open the path file. So there are a lot of tools here. Under here, this file here, you see the different options. You can open your recent document that you've done. Here you can open a new document, a path document. That's for here. You want to open a new document. And I said we have assembly document, drawing document, and normal part document. So you can make drawing from parts, make assembly from parts, you can save documents here. So and I explained the tools that we have. If you want to start any sketch, you just click on the sketch tool here. We have a lot of tab here. So click on the sketch tool. So click on the sketch tool to start anything. You choose any plane you want to use, whether using the front, the right, or top plane. Click on the front plane. Told you that this is the line tool. Like I explained before, this is the line tool to draw a line. You can just click on it, click on a point on the graphics window. This white place is called graphics window. So you click on another point, you can keep clicking on it like that. You can keep on clicking to keep on drawing your line. That's for a line tool. And click escape to exit the line tool. So I also explained rectangle, different type of rectangle. We have corner rectangle, we have corner rectangle is drawn like this. We have center rectangle, which is drawn from the center outward, and we have another type of rectangle called 3 point corner rectangle, I have 3 point center rectangle, I have parallelogram. So for a parallelogram is a slant thing. Just draw it like this. That's a parallelogram. So that for a parallelogram, you draw it like this. So for 3 points corner rectangle, just click on it. You click on 3 points to draw it. Then we are done. So 3 points center rectangle, click on the first point, the second point, and the center. It draws the rectangle from the center. So that's the fifth type of rectangle we have. So, and there are a lot of options here. So when we start the sketch, we'll explain more. So I just want to do a brief recap on the tools we've explained before. So we have the circle. Circle, we have center circle. Normal circle we know. Draw it from the center, click on this a point in the graphics window. That's your midpoint, and you extend it outward. That's you've gotten your circle. You have perimeter circle too, whereby you just click on points to draw your circle. You enlarge it like this. It has to do with the perimeter. Like perimeter, do you know guys know the meaning of perimeter? Is the total length of the circle. The total length. Let's say the total curve length. If you measure it, the total length in millimeter, that's a perimeter. So that's for a perimeter circle. We have the arc. Let me clear this place so you understand what I'm doing. So the arc two. The first type of arc we have center point arc. You click on a point that you want to use as a center point, you extend it outward, then click on another point, then you go like this, or you can go like this. You can just rotate it and stop at where you want to stop. That's for center point arc. The tangent arc, you need an initial line to draw down. You have a line, just draw it and draw the tangent arc with it. And just click on that edge. You have your arc. You can keep on drawing. So this arc will be tangent to the line here. For something to be tangent, that means where it starts, where this arc starts is where the line stops, and it follows like that. And the last arc, we have 3 point arc. Just click on a point, the start point, the end point, and how you want it to extend. Maybe you want it to extend very well or reduce it. Then click on somewhere to stop. That's 3 point arc. So I'm clearing my screen. I'm highlighting the sketch to clear my screen. So and we talked about polygon too. So polygon, when you click on this polygon tool, you can specify the number of sides. You can make it 7. Can specify whether it's going to be an inscribed circle or circumscribed circle. Just click on a point to draw the polygon. If you count this side now, it has 7 sides. That's 7 sides. And you can make it circumscribed. Circumscribed means that the circle is it encompasses the polygon. That means the polygon is inside the circle. But if it's inscribed, the circle is inscribed inside. So the circle is inside the polygon. So you can make it construction line. So if you tick anywhere you see this for construction, if you click it will turn the thick line to a faint and broken line. So if you tick it, you click it like this, it changes. So that's for a polygon, and I told you you can specify the number of sides. And let me clear this screen. Click on the escape key to exit the polygon tool, delete it, and click on this boss, this slot. This tool is called slot tool. It's a very easy tool in a point whereby you need to draw a sketch that is the geometry is kind of complex like this. Let me click on it. It's called slot tool. So the straight slot is the first one here. Click on a point, another point, and you can extend it like this. That's for a straight slot. For the center point straight slot, just click on a point, the center, and extend it, and also extend it like this. There's a difference between the two. This one is starting from here to here, while the center point is starting from the center and you extend it, and it's also extending at the same time in the opposite direction. So that's for the center point slot. And the we also have the 3 point arc slot, which is this. You just take one point, another point, and the third point. If it's 3 points, that means you need to click on 3 points before you start the geometry. So this is it for 3 point arc slot. So the fourth one is center point arc slot. So to draw the center point arc slot now, we click on the tool here, click on it here, click on it here, then you draw your center point arc slot. Done for that. When you are tackling sketch problems, it will be very useful. These tools that I'm explaining. Are you guys hearing me?
Yes.
Okay. Okay. So I've explained the slot tool. So another tool I want to explain now is the fillet. I don't need to explain fillet now. It will be very useful. I can just explain it a little again. I've explained it before, but let me explain it once again. The fillet is just meant to smoothen sharp edges. It's meant for the function of smoothing sharp edges. That's what the fillet does. So if you click on this tool here now, there is an arrow beside the fillet. You can decide to do a sketch fillet or a sketch chamfer. So chamfer means you are cutting it. You are not smoothing the surface, but you are cutting it at an angle. Let me do a chamfer now. I can do a chamfer for this edge now. I can do a chamfer for this edge and make it. Let me redraw the sketch once again. So I'll just click on this. Let me do a fillet first. So I can do a fillet here by clicking on the edge for a fillet, and also click on this edge to do a fillet. The fillet is very tiny, so I can increase it to maybe 100 millimeter fillet to be able to see it like that. So 100 millimeter fillet, or I can make it 200 millimeter so you guys can see it. So in short, what a fillet does is that it reduces, like it make a sharp edge, it makes it smooth, and what that does is it reduces stress in any part you are designing. We are making the sharp edge smooth. We are trying to reduce stress at all those sharp edges because stress concentrates on sharp edges. That's for if you are doing simulation and stuff like that. So That's for fillet. I can fillet this edge to do a fillet, and I can reduce it. I can dimension each fillet too. So I'm done for this fillet. That's fillet two. So I'm going to click on my control button and Z now to go back and explain the chamfer tool. So I want to explain the chamfer tool now. I'm clicking on sketch chamfer now. I'm clicking on this edge. I'm increasing it to maybe 300 millimeter chamfer. So it means that it will go in 300 millimeter. Let me do the chamfer once again. It's too small. That's why we are not seeing it. The millimeter I'm using before is too small. Let me click on 300 millimeter, and can you see? It's propagating 300 millimeter to the left, to the right, and also 300 millimeter downward from the edge, from the initial edge. So that's what the chamfer does. It just cuts it, like it cuts to the edge and make it angular. So I can specify if it's going to be angle distance or distance. I can specify the angle. It may not be 45 degree, but it's by default it's always 45 degree. I can change the angle to 30 degree to a particular place there too. So I'm just doing a brief. So I want to explain the ellipse tool, then I'll do a recap on sketch relations before we tackle a sketch problem today. So I want to explain the ellipse tool. This is an ellipse. Can extend it like this and just draw it like this. Can you see? It's an ellipse. So I will explain the smart dimension tool too. I said there are a lot of dimensioning tool. We have horizontal dimension, vertical, baseline, chain, a lot of dimension. But to keep things easy, we can't remember all this. In fact, you won't really know at the exact time that is this one I want to use, this one I want to use. That's why we have smart dimension. Smart dimension works for is a multiple purpose. So it works for every application. So it's preferable to use smart dimension directly instead of thinking of whether you want to use chain dimension, baseline dimension, or any other dimension here. So that's why I said smart dimension is the most important thing here. And it's not that just click on smart dimension to click on the edge that you want to dimension. For ellipse, what you just need to dimension is just dimension it like this. You can specify it to maybe 300 millimeter ellipse. So what we are dimensioning here now is the major radius. Now in an ellipse we have major radius and the minor radius. So this one is the major radius from here to here. From here to here now is the minor radius. So I can dimension the minor radius to what? To specify the height. How high is going to go. I can make it I can make it 100 or make it 150. Let it be half of the major radius. I'm making it 150. So it's half of the major radius. And also I can just create a relation, but I will explain that in relations too. So I've explained the ellipse tool now. So I also talked about different sketch entities yesterday. I talked about trim entities and all. So to keep it brief, I'll just explain the most important entities that we'll be using mostly. In these trim entities, there are a lot there, but I'll just explain one because I've explained these things before. So I'm just going over a recap. So trim entity, I'm clicking on the line here to create another line to explain trim entity. I'm just drawing like this. Click on my escape to escape key to exit the line tool. So I want to click on trim entity now. I said among all these trim entity, what the power trim does and what the trim to closest does is they are the two of them, they are the most important thing to take note. All the other ones you don't really need it. The power trim, the way it trims an entity is that you can use it to extend, you can use it to extend something, you can even use it to shorten it too. That's what power trim does. Any sketch entity, just extend it with power trim, or you can shorten it to any length you desire. That's for power trim. But for trim to closest, what it just does is that it splits those segments by interference. Because normally, if you look at this line, it's a full line on its own. It's not supposed to be splitted. But because we are using trim to closest, closest means that once it sides another sketch entity, that once it reaches the point of another sketch entity, it's like an obstacle. Automatically, it cuts it. So it recognizes that the sketch entity has already divided this line into two. So you just trim it like this. Maybe you need this part or you need this part. Just trim it, trim it. That's what trim to closest does. And let's move to convert entity. I won't explain this convert entity now because I said it's mostly useful when we are doing 3D. It's used to convert the edges of a 3D part into a sketch entity to reduce your time. It makes work faster for convert entity. So but for offset entity, I will explain this one. That's one application in 2D. So I'm drawing a rectangle now. So offset entity, what it does is it just offsets the edges, like it extends it. I can extend it by 50 millimeter. It enlarges it. It's not clicking on what I wanted to click on very well. So I'm clicking on offset entity now. So so I can reverse it. I can offset it outward and I can offset it inward by reversing it. This selection is meant to select everything together. But if I uncheck it now, I have to be selecting everything manually. But if I check it, it will select everything together for me. Bi-directional is for it to go in both ways. And also construction, when you hear construction geometry means that you want to make a thick line, you want to convert it to a faint line. So it's asking me that which of the two entity am I converting? Which of the two geometry am I converting to a faint line? It's asking me that should I choose to convert this geometry, which is the initial sketch, to a faint line, or the offset geometry to a faint line. So someone just joined. Let me admit the person. I'll continue. Uh, So I can try to convert the base geometry to a faint line, which is the initial sketch, to a faint line, or the offset geometry. So if I'm clicking OK now, and I didn't choose any option, so I didn't convert any of the geometry to a faint line. But I can click on my Ctrl Z to move back and click on offset entity once again and convert this base geometry to a
We
faint
can't see
line.
your screen again. No, we
Okay,
can't see your screen again.
okay, let me check. Okay, I'll share it again. Can you see it now?
Yes.
Okay, you can see it
Yes.
now. Okay, okay.
Yes, sir.
Okay, so let me continue. So, like I said before, the base geometry, I want to convert it to a faint line. That's what construction geometry means. So I decide to choose this option. So I'm converting it to a faint line now. So I'm choosing the base geometry now. So the base geometry, which is this one, has already become a construction geometry to a faint line. So I can click on my Ctrl Z to go back and try this offset entity again and decide not to convert the base geometry. I can convert the offset geometry to a faint line now. So I'm converting the offset geometry to a faint line. So now is this offset geometry that is a faint line now. And I've added dimensions. I can choose not to add the dimensions. So everything is in the option there. Just showing you how the offset entity works. So mirror entity. What mirror entity does is it takes, you can use a line as your reference. It takes something on the other end and copies it to the other end of a line. So you can copy it across a vertical line. That means the vertical line is the reference geometry. When I'm mentioning geometry, geometry means all the sketch I'm drawing here, they are geometry. So let me draw a rectangle here now. So I want to mirror the entity. So entities to mirror. So I'm mirroring this now. So said is asking mirror about where. So I'm mirroring about this line. Can you see? I'm mirroring it about this line. I've already clicked on copy, so it won't delete the initial sketch. But let's assume that I didn't click on copy, I uncheck the copy option. So it will just mirror it, like it will work like a cut and paste. Just copy it, cut it here and paste it here. You won't see anything in the initial place again. So there's nothing here again. So I can click on my Ctrl Z to move back again and do mirror entity once again. So mirror entity now, I'm mirroring everything here. So mirror it about this horizontal. So since I'm clicking on copy now. So I'm clicking on copy. So it will still be intact now. So I want to mirror it across the vertical reference geometry, the vertical line. So it's our reference geometry here. We are going to use the horizontal line as our reference geometry, which is this one. So entities to mirror. So I'm highlighting these two rectangles. Mirror about this line. So can you see it appears downward? So this is it. So the next entity we are moving to now is move entities. I can delete everything here and let's move to move entities now. So I'm drawing a rectangle. I'm clicking on move entity to move the rectangle. Entities to move. I can decide to keep relations or not keep relations. I will explain sketch relations. So let's keep down for now. So it's asking me that from where to where. So and it's asking me for a start point. So I'm using this edge here as a start point. So I can move it freely. I can decide to stop here. I'm clicking on Ctrl Z to go back one step again. And I'm clicking on move entity. That's already highlighted the entities to move. So I'm not choosing from to again. That from to gives it a free drag. I can just drag it freely. But if I'm clicking on X/Y, that means I have to enter a coordinate here. I can enter 200 millimeter, and you see it moves by 200 millimeter in the X axis direction. I can enter 200 millimeter in the Y axis too. So it moves by 200 millimeter in the Y axis direction. So that's how move entity works. So I can repeat it once again, keep on repeating it till it moves upward. I'm repeating it, repeating it till it moves upward. So that's for movement. So another entity we are going to talk about now is linear sketch entity and circular sketch entity. So I'm drawing a rectangle now. I'm drawing a circle in it to demonstrate the linear entity. So after drawing the circle, so I want to replicate this circle along the horizontal axis, and I also want to replicate this circle along the vertical axis. So what I'll do now is I'll click on this drop down menu and choose linear sketch pattern. So entities to pattern, I'll clear the selection and click on this circle. So I'm on checking this y axis direction one x axis. So I'm increasing it because the reason why everything is jam packed together is because of the spacing. So I need to increase the spacing to maybe 100 millimeter. Even 100 millimeter does not give us the required space that we need. So let me increase it to 300 millimeter. We still need to increase it more. Let me increase it to 450 millimeter now. So we can just increase it more, can increase the, so we are done with linear sketch pattern. And we can decide to do the linear sketch pattern to move it upward. That means we will just click on this y axis direction. We can highlight it, keep on highlighting it here, and choose it one by one. So we are moving it upward. While everything is jam packed this, I want to increase the distance, so I'm increasing it to 450 for this one too. Can you see? Everything has already moved upward together. So I'm reducing it and I'm increasing it back. So that's for linear pattern. That's how linear pattern works. So let me explain circular sketch pattern now. I'm deleting everything. That's why it's showing it like this. So I'm clicking on circle. I'm drawing a circle to demonstrate circular sketch pattern because the circular geometry will be used as the reference geometry. So we can move it along the circle. So I can decide to draw a circle here and decide to pattern it in a circular manner. So it's already showing it for me. So I can increase it, entities to pattern. I can choose a reference. I can let it be this point. So I can increase the number of what I'm going to pattern. So I'm increasing the number. It is patterning it from here in an in a clockwise manner, not anti-clockwise. To show you that it's a clockwise manner, if I reduce the angle to from 360 degree to 180 degree, you will know that it's a clockwise manner. So it's going from here like this, like this, like this, like this. So but I can reverse the direction for it to go in an anti-clockwise manner. So it's going in an anti-clockwise manner now. So I can increase the angle. So you notice that after I reverse direction, it is showing minus 180 degree because that other side is a negative axis, but the first one is in positive axis. So that's for circular sketch pattern. Just to demonstrate circular sketch pattern. So I have to delete everything again. So we've explained all the sketch pattern. I sent a picture to the group. I will send it again to explain so that you guys can be looking at it so you can understand sketch relations better. So on that picture, you can check the group now. I will send it now. So on that picture, you notice that we have horizontal. If you are checking it, you will see horizontal relation, coincident, concentric, tangent, vertical, midpoint, choroidal, symmetric, parallel, intersection, fixed, pierce, perpendicular, equal, collinear, along X. Let me admit the person that just joined. I need to change the settings. So, so I want to explain it one by one. So the first relation we have there is horizontal relation. It is meant to make something horizontal or a point to be horizontal to a line. Let me demonstrate it. Let's assume I'm drawing something here now that is slant. This line is slant. And this one is horizontal. So I'm clicking on my control to apply the sketch relation. I want to make this slant one also horizontal, like the way this one is. This one that is horizontal. I want to make the two of them horizontal. This one is already horizontal, so it's the second one that I want to make to be horizontal. So to apply the horizontal relation, you click on your control key, click on the two sketch that you want to apply the relation to. So click on horizontal relation here, you can see the sign. That's why I send the image, so you can use the image as a guidance. So click on the horizontal relation. That's all for horizontal relation, to make something horizontal. And it doesn't apply to line alone, it also apply to point. Let's there's a point here now, you want to make it in the same line as this point. So what you just do is click on your control key, click on the point and click on this. So make them horizontal. So it's already horizontal. So let's demonstrate vertical relation. So vertical relation is the next here if you are going downward according to the image. So vertical relation now, I'm also sketching a line to be slant, and I'm also sketching another line to be vertical. So I'm clicking on my control key, I'm selecting the two lines, so I'm clicking on the vertical relation to make them vertical. So the initial line, the first one that I drew that was slant, is already vertical now after I applied the vertical relation. And I will demonstrate it with the point also. I can draw a point now. So I want to make it vertical to the point here. So what I'll just do is click on my control and select. So just make it vertical now. That's all. I already made it vertical. So the next one there is parallel relation. So I'm drawing a line now. The line is just like this. the line is, let's say, like this. So I want to make it parallel to each other. So I just click on my control as usual. Click on the second line and click on the parallel relation here. This is already parallel to it. Parallel means they are both aligned in a way that the angle each line makes with the horizontal is the same. I can test it by drawing another faint line, a center line here. Can draw a center line here, draw another center line here. So if I'm measuring it now, from here to here is 23.17 degree according to my, so from here to here to is 23.17 degree to show our parallel relation that it is correct. I'm escaping it now. I'm clicking on my escape key to exit. I'm deleting it to demonstrate the next type of relation that we have, which is on the list there. We have perpendicular relation. Perpendicular means for something to be at 90 degree to the other. So I can draw a line. Maybe I'm drawing it like this, and I'm drawing another line like this. So normally, if you measure the angle between the two, they are just, it is just 55.37 degree. But we can make it perpendicular. We can make it perpendicular by adding the perpendicular relation. I'm clicking on my control key, clicking on both lines. So I'm making it perpendicular to each other. So can you see now? If I measure the angle between the two lines, they are at angle 90 degree to each other now. That's it. So the next one we are moving to now is coincidence. Coincidence means that we are trying to make something coincident with the other. They meet at the same point. So let's assume that I can use this line to also demonstrate it now. I'm clicking on this line now, this dot. I'm clicking on this line. So if I click on my coincident relation, it goes there to go and sit on this line directly. That's what coincident relation does. So we also have midpoint relation. You can say apply midpoint relation here. I can click on this point and this other point and apply midpoint relation. The point goes to the middle of the line. So that means the point is at a midpoint of the line, the horizontal line. That's to explain midpoint relation. Based on the diagram, you can see it's easy for you to understand. For the intersection relation, you can't really explain it now with a normal sketch. So as we move and go along with the class, we are going to understand intersection. So we just move to equal relation next. Equal relation. For all these relations that I mentioned, it does not only apply to lines, it applies to circle and arcs too. I'm just using line to explain. So I'm going to, for this equal relation, I can use circle to explain now. So I'm drawing a big circle and I'm drawing a small circle like this. And I can make the two circles equal to each other. So by making it equal, I click on my control and this second control, I can make it equal. I'm going back once again by clicking on Control Z. So I'm clicking on Control and the second control and make both equal again to show you the equal relation. So both circle they are equal. So that's for line too. It will make the length to be equal also for lines. So another relation there is concentric relation. Concentric relation is meant to make a circle to be inside another circle. It also applies to arc too. It is not only circle. I can decide to draw a arc now, a 3 point arc. I've explained arc before. So I can draw a 3 point arc, or I can draw a circle, a small circle too. It also applies. So I will just draw a small circle and exit. Click on my control. So I make it concentric. So concentric means that they are both sharing the same center point and one is inside the other. It's not a must for it to be inside, but they must share the same center point. So they must share the same center point like I said before. They can be equal, but they must share the same center point for them to be concentric. So I'm clicking on Ctrl Z to go back once again. But for colloidal relation means that they will share the same center point and they will be equal too. So colloidal now, I'm clicking on this and I'm clicking on the second circle. So I want to make the two of them colloidal. So they have same radius and they share the same center point now. So they already have same radius and the same center point by clicking on colloidal. So instead of clicking on equal then clicking on concentric, just click on colloidal once and you get what you want, because colloidal is the combination of equal relation and concentric relation. Equal relation in terms of circles, because equal relation is generic, it applies to lines too. It's not only circle, but in case of circle, equal relation makes the two circle equal. So the another relation we are going to focus on is fixed relation. So I'm deleting all this circle now. So focusing on fixed relation. So I'm drawing a line now. Fixed relation is meant to make the edge of something fixed and it won't move away from that place. That's what fixed relation does. So to make a dimension, to make something fully defined, a sketch to be fully defined now. So I need to first specify its dimension. Let me specify dimension to be 1, or let me specify it to be 50 millimeter. The reason why it's small now is because I already zoomed out. That's why we are saying small. So let me delete this sketch and start a new sketch again to explain it. So I'm drawing a sketch now, a line. I'm clicking on my smart dimension and I'm dimensioning it to be 20. So 20 now is not yet dark. Like I said, like I explained before, for a sketch to be fully defined, it should be entirely dark, but it's not yet dark. Why? Because it can still move freely. Can still move it. I can still move it. I can still move the sketch. I can move it. I can move it. I can move it downward too. I can move it upward, I can move it like I can move it like this. Why is that possible? Let's assume that I already make it coincident with the origin now. It will be dark now. So it will be dark now. But I haven't made it coincident with the origin. Let me click on Ctrl Z now. I don't want to make it coincident with the origin. I want to explain the fixed relation. So origin is a fixed space. It's already fixed there. But we don't want to make it coincident with the origin. We don't want it to go to the origin. We just want to draw the sketch and make it fully defined on its own. So we will just make this edge to be fixed. Click on this edge here. Click on the fixed relation. After clicking on fixed relation now, it is fixed at that point. It can't move again. That means I've already restricted its movement in all directions. So it can't move again. If you try to move it, it will tell you that it's fixed. And if you look at the notification here, it's showing that it is fully defined where my arrow is. So to explain another relation now, we are moving to collinear relation. What collinear does is it makes a sketch to align on the same line. Let's assume I draw a line here again. The two of them now, they are not parallel to each other because this one is slant, this one is vertical, and they are not even collinear. But with collinear, you can achieve you can make the slant one to be straight and they also be on the same line, on the same line. That's why it's collinear. So I'm clicking on control now, clicking on this line, then clicking on the other line and make them collinear to each other. So by making it collinear, they are both lying on the same line. That's why it's called collinear. So that's to explain collinear relation. It also applies to points too, not only lines. It also applies to points too. So the next relation there is tangent relation. To make something tangent to each other. So I can draw a circle now and draw a line here. Normally, this line it is straight on its own, but its starting point is not starting from where this circle stops. It's not starting from somewhere where this circle stops. So for it to be tangent, we need to make it tangent to the circle. When you want to make something tangent, if it you are making something tangent to the other now, so you need to meet it and create the tangent relation between the two of them. What tangent relation does is that it allows the starting point of the second sketch that you are trying to make tangent to the reference sketch. It allows that starting point to start from where that starting the reference sketch where it stops. That allows that one to start. So in case of a circle now, and they will go in line with each other. They can go in line. Tangent relation is useful when you want to do apply some 3D features. If you created something, the 3D model from a sketch that is not that tangent and is curved, is just rough, you won't really be able to create some features on it. If you tell you that the edges are not tangent. So I can make this circle tangent with the line, make them tangents. So if they are tangent now, can you see? It is aligned with it. And I can make this point here on the line. Click on my control, click on the point. I can make it vertical here. That's it. They are on the same vertical plane now. I already made it vertical, so they are on the same vertical plane. And I can make it horizontal too. I can delete the vertical relation and make it horizontal to it. They are the same horizontal plane, and at the same time it's still tangent to it again. So I'm deleting the relation and everything else. I'm moving to the next relation, which is symmetric. Symmetric for symmetric relation. This is how we will apply the symmetric relation. Let's say I'm drawing a line now. Symmetric relation works when you want to make the distance of two things from a particular place to be the same. That's what symmetric does. So I'm drawing another line here. Can you see the distance of the two lines? I can make them symmetric to each other. Click on my control and click on the three lines here. Okay, I can create a dimension from here to here. After creating the dimension, so I want to make the three symmetric. Clicking on my control, close four parts. Okay, okay. So I want to explain the symmetry relation. I don't know what's happening. Wait, let me resolve it. You want to say something? I think someone wants to say. Okay. So let's jẹ́ ká tún join again, jẹ́ ká join again. So sorry for I'm so sorry for the meeting ending. So I have to start a new one. Okay. So I wanted to explain the symmetry relation. So the symmetry relation now, so for the symmetry relation, I was trying to demonstrate the symmetry relation. So it's a relation. I want to create a line here. So not to waste time, let's keep the symmetry relation. I will draw something on the book about it. So let's move to the equal curve. It's not in this picture, but equal curve is also part of the relation. I explained it yesterday, but for those that were not there, let me explain it once again. So I'm drawing an arc now. Let's say the length of the arc is this. Another arc, the length of the arc is like this. So I want to apply the equal curve relation to both arcs. Equal curve length relation. So they are both equal in the curve length now. So to verify that they both have the same curve length, so we just have to measure it. Can click on the evaluate here and click on measure. So measure the first arc. The arc length is 114.63 millimeter. So let's clear it here and measure the second arc. The arc length is 114.63 millimeter too. That's to show that they have the same curve length. So they have equal curve length. That's how equal curve length relation works. So now that we've explained all the sketch relation, let's tackle some sketch problem. Like I said before, that we'll tackle it. We are both tackling it together. We are all tackling it together. So I'll just do one and let you guys try to tackle some others by yourself. So if you check the PDF now, I've sent the PDF before. Let me send it once again. Let me send it previous. I've sent it previously before. Mhm. So I'm sending it once again. So it will take some time. I'm sending it once again. So we are going to tackle the first sketch problem there. I'll show you how to start a sketch, how to make it fully defined. So it's very important. So I've sent it. So have you guys seen the PDF? So open it now. You can just take a screenshot of the sketch. I will take a screenshot and send it to the group. So I'll take a screenshot and send it to the group. But you can also take a screenshot also. I don't want everybody to see it by sending it to the group. So so I'm sending this to the group now. Sorry for so I've sent it to the group. Can you all see the sketch I sent to the group?
Yes, sir.
Okay. So we are tackling this sketch now. So the first thing to note is that we are sketching. Let's exit it. So click on the first step is click on sketch. You choose the plane you are going to start from. You can choose the plane from here and you can also choose it here too. So you can choose it here and choose it on the other side too. So you can choose the front plane from here and start your sketch by clicking here. Or you can click on sketch here. I've explained that before. So I'm clicking on sketch now to start a new sketch on the front plane. So this sketch now to start it, the first thing we need to note as we are seeing this sketch. Do you have any question? Okay. The first thing we need to know that we are seeing this sketch is how do we start it? As we are seeing this sketch now, the first thing we need to note is we are seeing a circle, another circle above and that is larger than it, and some other sketch geometry. We know that there are arcs here, there are circles here, there are arcs here. So we know that to start with something like this, you will need your line tool, you need your circle, you need your arc, you need your trim entity is very important because majority of what you'll be sketching now here is you will be sketching it at first and you now be trimming it out just like you are carving something. You want to carve something, you'll be trimming it out, trim the shape out. That's what you are doing. So I want to start now. The first thing is since you know that you need a circle. So for if you are looking at this sketch now, the first thing you need to do is you need to start from the circle that is inside. Start from the circle that is inside that has a radius of 27. Okay, the radius is not 27. Okay, I want to check the radius. And the first thing, the most important thing is also how to read the sketch too. Is also very important. So I want to read this sketch now to know the radius of the inner circle or diameter of the inner circle too. I can work with the diameter also. Okay, so the radius of the inner circle now is 27.5. So we already know that the diameter will be times 2. So we can do 27.5 times 2 is possible here too. So we can start with so we can start with so we can start with by drawing the inner circle. So I'm clicking on the circle tool here now. So normally this is something I can finish fast. I can finish it in a quick manner. So I just want to explain everything so you understand it very well. Please, if you don't understand anything as I'm doing it, let me know so I can go back again and explain it as I'm doing this sketch. So I want to start with the inner circle first. I'm drawing this. I can decide to do another one too again, which is the outer circle, which is radius of 45. Here they didn't give us the diameter, but since you are given radius, normally it's supposed to be diameter, but it is radius that are being given. You can just be multiplying it by 2. So you can start your dimension here. Dimension the inner circle to be 27.5 times 2, 27.5. Then you click on your shift key and the star there times 2. And you can also try to multiply it on your head too, but if it's very difficult, just multiply it with the normal star key on your keyboard. So we've already dimensioned the inner circle. So we are dimensioning the so for the start point now, I made sure that I'm starting it in the origin. You can choose not to start it at the origin. It's not a must, because if you start it outside of the origin too, what you just need to do to make the sketch fully defined is just click on that point, the starting point, which is this one here. Click on the point and make it fixed. Once you make it fixed, it acts at the origin as the origin for you. So it automatically acts as the origin for you. So you don't need to bother about whether you start at the origin or not. But best practice is to start at the origin, because if you are faced with some sketch problem, they may try to tell you that start the sketch as the origin, that the normal origin, the default origin, start it there. That's why I'm starting at the origin. So I'm dimensioning the outer circle now to be, the dimension of the outer circle is, dimension of the outer circle is, so we've got 45. Click on your shift and star times 2. That's 90. Let me add the person that just joined. So times 2. This is the outer circle. I've gotten it. So for us to draw, to be able to draw the lines that are in between the inner circle and the outer circle, that are across the inner circle and outer circle, what you just need to do is, you can see 30 degree here, 30 degree here, you can see a lot of things here. So the best practice is, first thing first, you draw your line, make it construction line, because you don't need it in this sketch. That's what construction line does. And we can make it midpoint. So if you are going up, it will be going down by itself too. You don't have to draw it downwards again. Double click to exit that point and start another point again. So you make it midpoint once again. What the midpoint line is going to do for you is, you can also draw another line again to, so we are going to offset it finally again. So we are drawing another line, make it construction line and midpoint. So it's going to be like 6 things that we are doing. So we are drawing another one here again. So we are now making a dimension between the slant one and the straight one, should be 30 degree. We are making the dimension here to between the slant one and the straight one to be 30 degree too. So as I'm making this one to be 30 degree, you notice that I don't need to make this one at the bottom too again, because automatically it becomes 30 degree. If you try to make it, it will show you error, that you are over defining the sketch. The most important thing about the sketch is always make your sketch fully defined. See, it's showing me that I'm over defining the sketch. That why am I adding another unnecessary dimension when there is one there that satisfies that function? So what we are doing next is, we are going to offset these lines. That's why we are making the line. So click on your offset entity. You are offsetting this first one. Change the offset distance to, we are changing the offset distance to 8. So we are making it 8 now. We are making it 4. Since that the total distance is 8, is splitted into 2. It's going in 2 directions. So we are making it 4. So 4 plus 4 we still later add up to 8. So we are offsetting this one too. Offsetting this one too. We are offsetting this too. Then we are done with the offset. So we are done with all the offset that we want to do. Oh, let me click on Ctrl Z back once again. So I'm going to offset it again. The issue is, I went to click on construction geometry, which is not supposed to be true, because I don't want it to be construction geometry. So that's it. So the remaining work here now is, I'm going to click on trim entity. We are trimming this side. The sketch that we don't need anymore, we are going to trim it. So we are trimming this too. Like I said, is that trim to closest. That's the most useful trimming tool we need. That's why I didn't really explain others. But if you, for curiosity sake, you can know others too. But since what you are, the aim of everything is to know the sketch you are doing. So all the inside here, we are going to trim everything we are seeing inside here. Trimming everything. Trimming everything. I know you will see error, but don't mind the error. Just keep trimming. You see error, but don't mind it. It's as a result of some conflicting relation, but as you are trimming everything finish, the error will disappear. Trimming, keep trimming, keep trimming, keep trimming, trim this, trim that. Yeah. Don't trim the center line because it will make your sketch not to be fully defined, and I will explain why too. Because it's the central line that is responsible for the offset. If you are trimming it away, it's like the parent feature that is the one that generates the offset. So if you are trimming it away, if you are deleting it away, that offset relation is going to be deleted automatically. Offset relation means that, sorry, I'm going to trim this. So I'm starting my trim entity again, trimming this away, I'm trimming this away too. So I'm going to trim this, trim this, trim this, trim this. If you don't understand anything, let me know. Maybe the sketch or how I'm trimming it or any other thing. Don't worry, the error will disappear. It will disappear by itself. The error will always disappear. What we need. So we are trimming it to get what we need. That's the most important thing we need. So we successfully trimmed all the sketch. We trimmed this side too. We don't need it. And also this side too, we don't need it. Let me add the person that just joined. Please don't if you don't understand anything, please let me know. So we are trimming, we've trimmed everything now. So this is the sketch that we need. We've trimmed it out. You notice that this side is still blue. So, no, we are not trimming this one out. I'm clicking on Ctrl Z back. So you click on the sketch, you notice that it is still blue. We have, this is how to read relation that we have on it. We have a coincident relation with this circle. That means it is coincident with the edge of the circle. And we have a coincident relation with the other circle too. It is coincident with the edge of the other circle too. But it is still showing blue. To know the required relation you will add, to know it, what you just try to do is try to move the sketch. See how it is moving. To know the required relation to add. Notice that it is moving freely like this. That's why it is still blue. So what's the required thing to do? Just click on your smart dimension, dimension it, make it 4. Notice that when I dimensioned it now, I made it 4. It turns back to black. That's how I knew my required relation to add. So I added it to make it fully defined. So you notice that everything is still currently fully defined now. So the next step, the two circles that are above it and every other thing that is above, we need to draw it. So go to the circle tool, click on your center circle. As I said, the circle tool that you'll be using mostly is the center circle. The perimeter circle you don't need it. I only brushed it to just explain. So I'm drawing this circle, drawing it here. So instead of drawing it, keep on drawing. I can use mirror entity too. So it has automatically clicked on this circle for now. So I'm mirroring it about which reference thing, reference sketch. It is this center. So I'm clicking on mirror entity once again. I'm mirroring these two circle again. About where? I'm mirroring it about the horizontal. So we've gotten the mirror, what we mirrored now. Can you see? We've gotten it. So normally I made a mistake. I should have drawn the second circle to and mirrored it too. So I would have mirrored the two together. So instead of wasting my time. So that's a mistake on my part. So I have to mirror this one too. Mirror about where? Mirroring about here. So I'm clicking on the mirror entity tool again. Mirroring it about where? I'm mirroring it about here. Done. So I've successfully mirrored it now. So what's left? What's left now is those radius 17 and everything you are seeing here now. We need to dimension it. These circles that we are seeing here. So the inner circle here is radius 10. 10. So the outer circle is radius 18. So radius 18. So to make my work faster, can you notice that as I mirrored it, mirror comes with automatically makes everything equal. So as I'm mirroring it, it is changing the dimension of the other circles to make everything equal. That's the importance of mirror now. So instead of adding dimension for this and start adding another dimension for the other circles too, it relieves you of that stress of adding multiple dimensions. So we need to measure the distance from the center, inner center here, to the center of the outer circle here. The center of here is 60 degree. So we are clicking on our smart dimension, measure it, measure it to be 60 degree. Can you notice as I measured it, everything is black. It has already become fully defined. Easily without having to do the manual problem, the manual going through the manual stress of drawing it one by one. Importance of mirror entity and trim entities. You can see it from this sketch I'm doing now. So I want to draw another circle now that we have a radius of 17. Sorry, I made a mistake while drawing the initial circle, this circle supposed to be radius there is 18, not the diameter. So I drew a circle, so I'm supposed to change it to 36. That's a mistake on my part, but at least it saves time. Instead of having to draw everything and dimension it once again, I just need to change one of it and everything follows immediately. So I'll change this one to 20. Can you see? So I'm drawing two circles that will intersect. Drawing a circle here. So I want it to intersect, touch both circle here. I'm drawing another circle here, or I can mirror it. I can mirror it about here, about this side, and I've gotten my circle. So I just have to dimension the circle and make it, since the radius in the picture here is 17, so we make it 34. So I'm making it 34. So the goal here is it is touching this circle. So as long as it's touching this circle, by making it 34, it's not going to move downward if I'm increasing it. Even if I want to increase it, it will only move upward. Like it will enlarge upward in an upward manner. It won't enlarge downward again. Because that's what I want to use it for. So I've made it 17 now. So the last thing for me to do now is I'm drawing a 3 point arc for of radius 5. So I'm drawing an arc, it's 3 point arc. I'm clicking anywhere on this circle, doesn't matter. On anywhere on this circle, I will use my sketch relation to define everything later. So I just need to edit the dimension to be radius 5. Yeah, it will become smaller. I understand. So I'll mirror the entity again. I'm mirroring this arc. I'll mirror it about this horizontal reference line, successfully mirrored. So I'm mirroring it again. I'm mirroring this two arc about this horizontal. So the first one was vertical line. This is this. The second one is horizontal line. So I'm done with that too. So to make it align like the way we are saying it here, what I just have to do now is this arc that I drew now, I just have to click on my control, click on the arc. That's why I said this is where relations comes into play. Click on this circle and make it tangent. Can you see? It is tangent. And others who are obeying it, the way I'm changing the initial one, it's like you are changing the source. So the it's like take this sketch as the this one that I did before as the parent. As you are changing the parent, the child will obey. We still go to parent-child relationship in SolidWorks too. That one is under 3D. I will explain those parts. We are still in 2D now. So so as I'm clicking on this now, the child are also updating to reflect the change I did. So still clicking on my control key, click on this circle. I'm making it tangent again. So the child just obeyed the parent one. Can you see? It's already black. This is what you just need. The next thing left for you to do now is just to trim it. You'll be wondering that how am I going to trim it to get what I want to get? So you just click trim entities and start your trimming. Start from here, then here. Can you see it's looking like it now? Here trim. Trim it here. Okay. So we are still going again. We are trimming this side, trimming this side, trimming this side, trimming this side, and also trimming this side. You don't need it. So we are trimming this, trimming this, trimming this, trimming it, and trimming it too. So we don't need it. So let's go here. So we are trimming this, we don't need it, trimming this, trimming it, trimming it. Oh, we need that. Let me click on Ctrl Z and start trimming again. So trimming it, trimming it. So we are trimming it like this. We are trimming it and trimming it. We are trimming it again. So trim, we trim here. Okay. Let's look at it again. Is it like it now? I think we've gotten what we want. So this is the sketch we've been trying to do. Now, this is it. Is there a part you guys don't understand so I can explain it again? You'd have told me if you don't understand anything as I'm doing the sketch, you should have asked. Or you understand how I did the sketch.
So
Okay, let me go back to the sketch. Okay, what do you want to ask?
I just want to ask you a question.
I can't hear you very well.
Can you hear me now? I want to
I can hear you. I can hear you now. Your network,
okay. I want to ask because I've already tried. Oh, shit. Ah, need to be done.
the network.
Ah, oh.
You have network issue over there.
Maybe I'll just type. Maybe I'll just send it to you on WhatsApp. There.
You know
It's not
what?
about
If you want
the. I
to
don't
ask
think it's about.
anything,
So,
if it's after this class, send it to the group
okay.
so others can also benefit if I
Okay.
reply you. Or you can also type your question too.
Okay.
That's
Fine.
another suggestion. So type your question
From this
here.
place,
On this in the chat box,
uh,
you can type it here too.
okay. I've seen.
Okay, which diameter? Someone said the diameter of the tackle is 32. It is 36 now. There is no 32 diameter circle here. It is 36. 18 times 2 is 36. I hope I've corrected the person. Is that person here? So I think the person is here. The person can reply to okay. What of others? Do you understand how I did the sketch? Or you go and practice it. So you practice it, you will be able to know if you know it or not. Let's just finish with only this sketch. So you can just stop with this sketch today. So for the assignments, because I have to give assignments for other sketches too. So you guys can sketch and so you can sketch it and just the submission will be how should I do the submission? Maybe you send it to my DM. You just snap what you sketched and send it to my DM, but that will be too much. You can just send it to the I will think of a way for the submission. So after the class, I will post the assignment. That's the task for everybody. So always dimension my drawing. I've tried it before. Okay. You asked that my question is that is it a must for me to always dimension my drawing? I've tried it before, but what I did is underdefined. See, I already explained it before that to make okay to screenshot what? I don't know what you mean by screenshot. What are we going to screenshot?
That you
Like
said you snap it. We should snap the assignment. I thought you said we supposed to be screenshot instead of snap. No, you
no,
said
no, like
about the assignment. That's what I'm saying.
okay. You screenshot it. Yes. You
Yes.
screenshot it. But I will tell you, I will inform you guys about the mode of submission, how you are going to submit it. But I will drop the assignment immediately after this class. I will drop the assignment so you can go and attempt it. So for the question you asked, I already explained before that to make a sketch fully defined, there are two things to it. Is either you can either dimension to make something fully defined, or you can just use even only sketch relation, you can make it fully defined. So it depends on the situation you are in to make it fully defined. So if you are dimensioning and it's not yet fully defined, I already gave one trick that if you know your sketch relation very well, the trick is if your sketch is maybe you are trying to define a sketch and it's not fully defined, the best trick for it is if you know that this sketch is still blue and it's not yet black, the best trick is exit. You can click on your escape key and use your normal mouse. You can just use your mouse. Sorry, don't click on escape key. Escape key is just to exit any tool you are using currently. So just use your mouse to drag that sketch. Try to drag it sideways. If it's still dragging sideways, maybe something related to something you think of a relation that is related to that area, maybe that's where you need to make it fully defined. But if you are able to drag it from that place too, drag it, keep on dragging it in direction you are dragging it. That's how you know if a sketch is fully defined or not. But it still boils down to your knowledge of sketch relation. You need to know sketch relation very well. So you just master that sketch relation very well. So you can just listen to this class again. If I upload it, I'll send the link to the group. So you listen to the class and try to master that sketch relation very well. It's very important for the sketch relation.
Okay.
Okay,
Okay,
so
thanks, sir.
I can just let me just demonstrate something for you now to that. So I can you guys can let me just screenshot what I did now. I will send it to the group, this sketch that I did. Or don't let me screenshot it. I just want you to use it for to enhance your to enhance what you want to do. So let me screenshot it. I will send it to the group. I will send it to the group after the class. That this is what I did. So you can use it as a guidance for your own. So I'm deleting the sketch because I don't need it. So I'm deleting it. So I want to just put a guidance through so that you can understand what I said about sketch relation. So let's assume that I'm drawing something here now. I know I can't fully explain it like the way you are going to understand because these things has to do with the kind of scenario, and I can't just simulate every scenario that you will experience in future. I can't simulate it now by just drawing any sketch now. You can experience anything, you can face any difficult sketch problem for you to understand it. But it's by thinking, and once you know your sketch relation very well and think very well. But I will explain something now. Let's assume that I want to draw a circle again. I'm drawing a circle here. I'm drawing an arc. Can you see? The problem I have now is how do I make this my sketch fully defined? The first thing I'll think of is dimensioning is okay to know the extent of what you are doing. So I can dimension. I can dimension this. Can you see? I'm still dimensioning it. It's not yet fully defined. I'm putting dimension here too for this. Still not yet fully defined. I'm putting another dimension here again for this. Still it is not yet fully defined. But some of the things that makes it fully defined is see try to I will just I want to dimension this also. Not yet fully defined. Fully defined means that you define it up to the extent that you won't be able to move it again. So let's say I've dimensioned everything, but I'm still facing that difficulty of making it fully defined. I'm just thinking of how can I make this thing fully defined now. Okay. So like I said, the rule book is maybe you want to make this rectangle fully defined now. Just try to drag the sketch. Try to drag it. You can see the way it's moving. You can see that it is not defined to a particular point. Yes, you have the height and you have the width, but you can see that it is not restricted to a particular point. What is the issue? How do you rectify it? You can either rectify it by clicking on here, this one, and clicking on this line too. You can make them coincident. Can you see what I'm doing? I made it coincident now. Though it is not yet fully defined, but it's part of the process. But you notice that this side is already black. Or another option, I can use dimension without using these two. I can just click Ctrl Z to go back and click on the dimension once again and click on it like this. Do you notice what I did now? It's already dark around this side too. Can you notice this side is already dark? Which means along this area, I've fully defined it along this side. Though it is showing that the sketch is still underdefined because everything is not yet fully defined. But it's telling me that this part of the sketch is already fully defined. It's already showing that it's black. Now try to drag it. You can notice that it is still dragging like this. Even though the radius here is being defined as 58. But you notice as I'm dragging it, in fact does not affect the radius because the radius is not fixed to a particular point. The radius can move about. Can you notice the center point of the radius? See as it is moving. See as it is moving upward. It is moving upward. So which means it is still free to move. So the radius is not yet defined. Even this side of the sketch is not yet fully defined, of the rectangle is not fully defined. Even though if you notice that you can't just drag the edge of the sketch, the width is already defined. That's why it is black. But you notice that you can still drag it sideways along the horizontal plane. You can still drag it. Ìyẹn ni pé àìtí dè é mọ́bì kan. It's still along the, you can still drag it along the horizontal plane. We've not yet bolted it. It's like, let's assume, think of it as a fastener. We've not yet bolted it to a particular point. So how do you bolt it to a particular point? Another option for you to make it fully defined. You can click on your control key, go to this line here. You can use any line. Oh. I'm just using this one. That midpoint, you know what you do? To do that, you just over your mouse, place it on this line. Automatically, that's the advance of SolidWork. Automatically, that midpoint will show, will pop out. While clicking on your control key, just click on the mid, this point here. Click on this point here, the midpoint here. That's the origin. You can just make it coincident. No, it will show you error because something is conflicting with each other. But we can, if you make it coincident, assuming it's possible, it's because the reason why it's showing error is because something is conflicting with each other, and I don't have time to be explaining that error now. So we haven't really moved to explaining error in SolidWork. I'll still explain errors to you guys and how to rectify errors in SolidWork. But for now, the error is showing is because something is conflicting with it. So we have some conflicting relations there. So I'm clicking on Ctrl Z to move back again. Now I click on Ctrl Z. So I don't want to go through this route. I can go through another route. So instead of doing this, I can click on my dimension. Can you see? I'm using dimension to make it fully defined now. Can you see? I want to dimension it. Showing me I want to make it maybe like 25 centimeter millimeter. Sorry. So I'm making it 25 millimeter now. Can you see? It's already fully defined on the rectangle side. So for the circle now, do you know why the circle is not yet fully defined? Even though I've already defined the dimension. The dimension is just there from, it's just there for you not to be able to extend it or magnify it or increase its size by increasing the radius. You can't increase its size again, but you can still move it about. You can move it. You can move it. You can move it. You can move it along anywhere. So you can move it. Can you see I'm moving it? It is still possible for me to move it, but I don't want that. I want it to be fully defined. So another thing to do is I want to restrict this movement along the vertical axis. I can also move it along the horizontal axis too because it is not yet fixed on the horizontal axis too. I can still move that one too. But I want to see the movement along the vertical axis. So I want to dimension it now. I can dimension it 1. And instead of dimensioning it, I can also do another thing too. But let us dimension it. I'm dimensioning it now to make it maybe like 150, or let's increase it to 180. 180. Now we've gotten the dimension, or let's make it 200. Can you notice that it is not yet fully defined again? Okay, invalid geometry because I've already defined the radius, so it won't be possible. So I'm going back to 150. Can you notice that still it is not yet fully defined again? Let's make it 180. 180. Okay, it is not yet fully defined again. But how am I going to make it fully defined? Because the reason why it's not yet fully defined is because I can still move it along the vertical axis again. That I said one of the key things. So to make it fully defined now is I can dimension it from this edge here to this edge here. If I dimension it, it will become fully defined. And I can decide not to do that too. I can delete the dimension and click on the sketch, the midpoint of the circle, and this origin. I'm clicking on my control key. Make sure you're on your control key so that if you click on one, if you are trying to click on the other, it won't deselect the previous one you clicked on before. So I'm clicking on my control key and selecting the 2 points. So I'm making them horizontal to each other. By making it horizontal, can you notice the circle is now black? It is black now. The arc is not yet fully defined. Do you know why? Because the arc is still free to move. To make sure that arc is fully defined or not, to know how to make it fully defined. While I can still move the arc like this. Can you see? We can still move it. We can still deform it. We won't be able to deform it if it's fully defined. So to make that happen, to make it fully defined, what's left is tangent relation. That's why I say you need to understand your relation very well, because relation is the key thing in making something fully defined. I can decide not to use some dimensions here and just use ordinary only relation, and I'll make the sketch fully defined without using any dimension. It is possible. But I just want to use dimension and relation and mix it together. So I'm clicking on my control key and clicking on this vertical line here. I want to make both tangent to each other. Can you see it is tangent? It is not yet fully defined again. Why? Because I can still deform it like this. I can still deform it like this. Why? It's not a tangent to the other circle. So I just need to make it tangent to the other circle again. By making a tangent to it, now it's fully defined. So the best way to help yourself is practice that sketch relations. Look at the image I sent to the group. Look at it. Try to look at all the sketch relation inside your software. You can just keep drawing different line and use it to practice the sketch relation. By the class is just meant for guidance. I can't help you practice it. It's by practicing that's how you can master everything. The way you are seeing that I'm taking the line and circle and everything, I know how where everything is practice. There's no magic about it. So if you practice all the sketch relation, number one, and also use them. After using them, that's when you can get it. And the key rule in making a sketch fully defined is after you've done maybe what you know, and you notice that this sketch is not yet fully defined, maybe the edge of the line is still blue, or maybe the line is still blue, just try to move it. It's by moving it that's when you know, okay, maybe I will need to add tangent relation, okay, maybe I need to add horizontal relation between this point and the origin, or maybe I need to fix this point to a particular area. After making it fixed, it will be fully defined. So by dragging it, you can drag it, see the direction in which it is moving, or try to expand it. If it's still expanding, maybe you've not yet dimensioned the circle, that's why it can still enlarge or reduce. So if you dimension it, it will reduce down, it will stop down from happening. So try to move it around, see how it is moving. How is it moving in relation with the other line you've drawn, or maybe other sketch you've drawn there. That is the key to making a sketch fully defined. That's how you can master the fully defined thing. But to sketch normally, to keep drawing lines, circle and everything, to know how to start your sketch is not really hard as making a sketch fully defined. That's the main goal, to make it fully defined, how to start it. But I'll drop the assignment on the group and you can use it to practice. So I need you all to submit it. So I will discuss the mode of submission with you guys. So I'll communicate it, and everything else I'll let you know on the group. So that's the end of today's class.
Okay, thanks, sir.
Okay. Can
Thank you so much, sir.
Yes, sir.
Okay. You're welcome.